I'm Marco van Leeuwen, the spokesperson of the ALICE experiment at the LHC. Welcome in the ALICE control room. ALICE is one of the 4 large experiments at the LHC. The experiment is built and operated by about 1,000 scientists and engineers from about 40 countries around the world. And we are getting ready to take heavy ion data in this moment. The heavy ion collisions allow us to recreate the conditions from just after the Big Bang in the laboratory and to study the properties of what we call the quark-gluon plasma. So normally quarks and gluons are bound into protons and neutrons in the atomic nucleus. But when you collide heavy nuclei, you get very many quarks and gluons, a very high density, high temperature, 10 to the 12 Kelvin. So this is more than 200,000 times the temperature of the sun. And in that case, the quarks and gluons are what we call deconfined. They can move freely throughout a larger volume in the colliding system. So in a kind of little bang nuclear soup that we make in our collisions. And with our new detector, we can record 50,000 lead-lead collisions per second. And this is special because we really record every collision and then we process it online with a big computer farm. And with the upgrades, we can do new types of measurements. And one very important one is that we can measure thermal radiation. So as I mentioned before, the plasma is very hot, 200,000 times the temperature of the sun. And it emits photons, but also electron-positron pairs, which we can measure with our detector. In addition, we can measure what is called heavy flavor quarks or heavy quarks. And these heavy quarks, they are interesting because they are formed right at the start of the collision, then they go through the plasma and then they decay, and we can identify them in the final state at the end of the collision with our detectors. And that way we can study interactions between quarks and the quark-gluon plasma. We're very excited to see this very large sample of lead-lead collisions and to start collecting this data. Of course, we're also a little bit nervous because the detector is completely new and this is the first time that we will see a large number of lead-lead collisions with the new detector. We're very confident that we'll get a very large sample of these collisions and that will allow us to analyze many new things in the coming years.